All right, hi everyone. How you feeling? It's the end of the day. I'm the last thing between you and drinks on the roof, so I will take my time. I'm really excited to be here and see this huge audience. It's kind of crazy. GraphQL is 4 years old, but it's only been public for a little over 1 year. And when we first open sourced GraphQL, if you told me that a little over a year later, I'd be closing out a conference dedicated to it, I probably wouldn't have believed you. And really, at that time, I wasn't even sure if GraphQL was going to be relevant outside of Facebook. Of course, you all here today have proven me so very wrong, and I'm thankful for that. It's actually really amazing that today, almost all of the talks you heard were from people outside of Facebook, all using GraphQL within the last year. It's amazing. And our community, our GraphQL community, which is way bigger than just the people who are in this room, has been growing rapidly, way faster than I've seen some of the other communities that we've started at Facebook grow. And speaking of these expectations, sort of shortly after we open sourced GraphQL last year, I started to scribble down what I thought would happen. It's kind of like my best case scenario for a secret master plan for GraphQL world domination. This is what it looked like. Yeah. First, I thought, we'd see some hobbyists, some personal projects in the first few months, because they've got nothing to lose. Why not try something new? And then maybe in the first 6 months, we'd see it implemented in a couple new languages. That's why we shipped it as a spec rather than just software. And then maybe somewhere close to the 1 year horizon, we'd start to see some startups and some riskier, smaller crews take on GraphQL. And maybe at a 1.5 year mark, we'd see some really cool tools for using GraphQL. And then closer to 2 years, we'd see medium-sized companies. And then closer down here to 4 years, we'd see big companies and tech giants. For the first few months, I was pretty excited. I was like, oh yeah, this is happening. This is awesome. And then I saw a handful of people, a lot of them in the room, some of them who did the tech talks, start to pick up GraphQL and start some of those early personal projects that were really exciting. Then we got here way faster than I thought. So I thought it was going to take about 2 years for GraphQL to get implemented in most major languages. So I put a rough line at 10 languages. That happened in 3.5 months. It's blown out of the water. And I think it's pretty safe to call GitHub a large company, maybe even a tech giant, and they're, of course, rolling out public GraphQL APIs now. Now, we're not to this last step, ubiquity. We're not here yet. So we have a lot of things that we still need to build, but I just want to say overall, I'm just so impressed by how quickly we've blown away my totally wrong assumptions about what would happen. And for those of you that I haven't had the opportunity to meet yet, hopefully I'll get to meet some of you up on the roof later. My name is Lee Byron. I work at Facebook on a team called Product Infrastructure, where I was one of the co-creators of GraphQL 4 years ago, and I now have the distinct pleasure of managing the evolution of the GraphQL language and help it integrate into some of our other services at Facebook. So since the creation of GraphQL, I've watched our use of it evolve to cover more of the Facebook product, as well as watch GraphQL itself evolve to handle different scenarios and use cases. And even when we open sourced GraphQL last year, we were in the middle of one of the most significant evolutions of GraphQL since its creation. And over those 4 years, I've learned a lot about how to best use GraphQL, and today I'm going to share some of those things with you today. But we've also heard a lot of stories and practical advice so far, so I want to go further than that. I want to talk about some of the advice that I can provide from building and scaling and using GraphQL services, but also the best practices from building GraphQL itself. And then after that, I want to talk about some of the stuff that's guiding the future evolution of GraphQL, since I know that's kind of a popular topic. But before we do that, let's rewind a bit and look at a brief history of GraphQL. So hopefully it's interesting to hear a little bit about where this thing came from, and also maybe dispel any notions that kind of GraphQL arrived into this world fully formed in the state that you find it today. Certainly not true. So first came the original idea, which came from my coworker who's sitting in the back, Nick Schrock. He introduced what he originally called Supergraph. So he was one of the founding members of our product infrastructure team, and up until this point, he was helping to build our server's data loading and privacy checking abstractions, and he had this idea that we could take all of the work that we had done so far and then expose it over an API for our mobile apps, which at this time were just getting rebuilt. So Nick built a prototype of Supergraph really over the course of a couple days. Then, enough of us were excited that we started doing the initial development of what would be the very first version of GraphQL. I was working really closely with our iOS team on improving their newsfeed API, and so Nick and I started to work together to adapt Supergraph to support newsfeed's use case. And then Dan Schaefer, who's also here today, was an engineer on the newsfeed server team, so he definitely was part of making all this possible and joined our crew as well. So things happened quickly, and we evolved GraphQL to meet the needs of the iOS newsfeed, and within 3 weeks, we had something that they could use, and then a couple months after that, we had completed support for all of newsfeed on GraphQL. And then in August of 2012, we launched this new app, the new iOS newsfeed, and when other teams saw just how fast it was, and then heard from that team about the developer experience, we were quickly inundated with requests to extend GraphQL to support more products at Facebook. First, we had profile, then photos, groups, and events. And this is when we actually bothered to form a team around GraphQL so we could support this thing that we had built. And during this time, we learned a lot about how to design good APIs, and I'm going to talk a little bit about that later, but most of our work in this time was just making sure that the type system continued to make sense as we evolved it over the 4 years. We heard a little bit about that in the panel today, but I'll talk about that as well. But also in this time, we encountered all the different use cases that we had for GraphQL that we didn't anticipate. So during this window of time, we added fragments, mutations, subscriptions, native code generation, persisted queries. We built graphical. We built relay. So a lot of the stuff that's either been folded into GraphQL or has since become best practices or other open source projects were all started or were built during this window of time. Then in January of last year, Dan Schaefer spoke publicly about GraphQL for the very first time in a talk at the React conference in 2015. And honestly, we were just totally overwhelmed with the reception. It was like a footnote in a conversation about kind of how we were building things at Facebook. And people grabbed onto it and said, when can we have this? We're like, whoa. This was not supposed to be an open source announcement. We just wanted to tell you what we were working on. So this got us all fired up. We were like, all right, this is great. We got to figure out how to share GraphQL with the world. But what does that mean exactly? How do you do that? You know, GraphQL server was tied deeply into how Facebook worked, and we didn't really know how to extract it. But we also weren't that proud of just how complicated GraphQL had gotten over the previous years of adding all these additional things into it. You know, all these quirks and inconsistencies and the assumptions that we made when we first started GraphQL back in 2012, they were all still there. So we decided to reevaluate. We redesigned all the details of GraphQL. We made improvements. We fixed inconsistencies. We redesigned the syntax and the semantics in order to incorporate everything that we had learned over this window of time. And this process took months. It required a way more deliberate and careful process in comparison to the early rapid iteration that characterized the early development of GraphQL. And this ended, of course, with us open sourcing a specification that describes GraphQL and how it works, as well as a new reference implementation written in JavaScript. And we chose JavaScript not just because we like JavaScript, we do like JavaScript at Facebook, but because it's a ubiquitous language. More people know it than almost any other language. And it let us build tools on top of it that were very portable. In fact, the version of Graphical that we rebuilt during the same window of time in open source shortly after this is built on top of GraphQL.js. And then anyone in the audience who's maintaining an open source project knows what I mean when I say that open sourcing something is a beginning, not an end. So we knew that we were going to get a ton of feedback on this thing that we had just announced, or rather, we hoped that we would get a lot of feedback, and we definitely did. And so we released GraphQL with technical preview right in front of it. We did that on purpose to set expectations. This is something new. This is something that we were still working on, and it was going to continue to evolve over time. And during this period of time, we started to see all the things that a lot of people have presented about today. Implementations in GraphQL started by the community. Today, you can find that in over a dozen different languages. And I won't go deeper into that because we already saw in the keynote this morning just how many awesome projects are being built in GraphQL. Which brings us up to recent events. So a little over a year ago, GraphQL is being used not just at Facebook, but at a whole bunch of companies, big and small. And then last month, to reflect this, we finally removed that technical preview moniker. And we launched a new website at GraphQL.org to help people learn more about this thing that we had all built. And if you haven't checked it out yet, you definitely should. A lot of the community members, folks in this room, contributed a lot of the work involved to make this thing work. So it's really an effort of the community. And so as GraphQL evolved within Facebook over the years, we've added a lot of stuff to our GraphQL API. And over this period of time, we've learned a lot about what's important and why when designing those APIs. So I want to talk about some of these best practices that we've boiled down from the lessons that we've learned. And since we've already heard a little bit about some of these best practices, especially around clients, and my coworker Joe already talked about clients, so I'm going to focus specifically on API design. Well, let's jump right into it, all right? Most important, naming matters. We already heard a little bit about this in the panel. What do you do when you have to change the name for something? Naming things is super important in GraphQL APIs, especially since if you're not used to designing APIs, you might think like, we'll come up with a good name. If it's not good, whatever, we'll refactor it. Refactoring's easy. But in a GraphQL API, as soon as a client is making use of a field, you're kind of stuck. A naming mistake can be really expensive. So beyond silly mistakes, hopefully we can avoid those, an important question to ask while designing APIs is, will a new engineer understand this? And that means no code names or server-side lingo. Imagine that most of the engineers that are going to be using your API might not find it so easy to go figure out how that field maps to some underlying system. Maybe they're spending all their time in an iOS or an Android code base, or they're just new and they can't figure that out. So it's really important not just to have names that are good, but to have names that are self-documenting. And also, we're kind of spoiled by really cool tools like GraphQL. So most of us don't actually read API documentation. We just go here and we start typing what we think the thing will be named. And if something comes up, we're like, oh, cool, that's probably what I want. So naming things that adhere closely to what those things actually do is really important to help make this experience actually work. All right, naming matters so much when we talk about GraphQL, because we talk about GraphQL as being versionless, a versionless API. As long as we only add to it, all existing queries continue to work, and you don't need versions. And I often hear, yeah, okay, that's great in theory, sure, but how do you actually handle breaking changes in public? I'm like, no, actually, at Facebook, we don't do breaking changes. They're extremely rare. And that's because we design GraphQL APIs with designing for the future in mind. So we ask ourselves this: what would version 2 look like? Not version 2 of the API, version 2 of the product or the feature. So usually when we're designing an API, we have some product or feature in mind, and we're mapping from that back to the API that we want in order to enable that. So think about, what would the next version of that thing look like? Will this API support that magical world that you've dreamed up? If not, maybe your API isn't quite right yet. Spend that time to think, how will our product evolve in the future? Another important lesson that we learned when we were first rolling out GraphQL in the beginning was to stop thinking in terms of endpoints. And this is actually harder than I thought it was going to be. Most traditional APIs, they start with some new product experience, and then they work backwards to design the API endpoint for that product experience. But of course, GraphQL exposes all the data from a single endpoint, so this habit can be pretty hard to break if you try to just shove it into your schema this way. And this is especially hard for things that we don't typically think of as objects in a graph. One example that comes up often is search. So with search, it's immediately obvious that you eventually want to get to objects in a graph, but it's maybe less clear how you would get there. So if you're thinking in terms of endpoints, you might start with creating one-off objects that are really defined only as their purpose as an endpoint, as opposed to describing the semantics of the data that you're modeling. And if you instead frame that problem in terms of objects connected in a graph, and you separate the data away from the feature that you're building, you can do a lot of cool stuff. So for search, this might lead to a search type in the graph that you can get from a particular query string as an input. And once you have that object in the graph, you're back to the same kind of data semantics of relationships between objects. You can go from your search object to result objects. And now that search is just another object in the graph, you can start to imagine new use cases and how you might connect that object to other objects. So here's just one suggestion. A search might point to other searches to tell you suggested searches based on the one that you just did. That's how type aheads work. And this has the extremely powerful outcome of creating a single cohesive graph that allows API users to create subsets of your API, of the API graph, in ways that you might not have imagined when you designed it in the first place in order to enable new kinds of product experiences that you never thought of when you were building that API. Related to that, when we're modeling data, we want to model as objects in the graph. it's important to stay away from trying to model them as the view that we're going to support, and instead stay focused on that semantic data. So here's another question. Will this work for future clients? Usually when we're building an API with an initial client in mind, like an iOS app, we think about, is it going to work on a desktop app, a feature phone app, maybe an app for a TV, that all might have different demands, but still access the same data under the hood. We want to make sure that we're not tying our APIs too closely to the demands of our initial client. And at Facebook, this actually was really important because we were really careful when we were designing that newsfeed API to stay as semantically pure as possible, and that enabled later pretty wild experimentation with the newsfeed interface in apps like Facebook Paper or Facebook Home. And let's look at this as an example. So say we want to suggest some gift cards when it's our friend's birthday. It might be tempting to look at this mock-up and then come up with this query, right? We got a product that we want to know about, and then we have some attachment data on our story. But of course, we want to model the underlying data and not just the view. So maybe we actually want something more like this on the right, where instead what we get is a pointer to that product, and we can start to ask a little bit of questions about that thing on its own. And then here's some piece of information that's really not about the product, it's about a representation of it. We can include that as well, but we can give it something with a more semantically reasonable name than just subtitle. Doing this is cool because as we play with this and as our designers come up with more interesting ideas for how we might represent this, it's really easy to later change this query to represent the slightly different version of what we want without having to go back to the server and say, actually, instead of attachment image, can we have this attachment big image? And instead of attachment title, can we have attachment short title because we're running out of space? Don't do that. Just model the data. Shortly after releasing GraphQL, a lot of the questions that I heard and a lot of the topics that we've heard today were like, how do you do blank in GraphQL, right? Authentication, authorization, caching, database query optimization. And for us at Facebook, the answer is almost always, you don't. You don't do that in GraphQL. You know, GraphQL is designed to be this thin interface that sits atop all of your existing systems and systems yet to be built. And this is one of the first lessons that we learned when we were building GraphQL at Facebook. And it doesn't mean that you can't have those things. It just means that the GraphQL service layer is probably not the right place for them. And by handling authorization, database access, and all of these other concerns below GraphQL, the engine itself can then end up being pretty resilient to swapping those implementations out in the future as you end up migrating between different services and your platform evolves. So Dan Schaefer, one of our co-creators, did a really awesome talk about this year at React Europe, so I really highly recommend that talk. And then Robert Zhu, who's also on our GraphQL team, wrote an excellent guide that goes into this in depth on the GraphQL.org site called Thinking in Graphs. So when GraphQL should be thin, it should also be a seam between the semantic meaning of your data and then how that data is actually stored and retrieved. And that means hiding some of those implementation details. And so, so if some implementation detail ends up exposed that might change in the future, some client inevitably is going to rely on it. We had one example where in order to figure out a photo, you had this ID for the photo that was the ID for the album it was in, and then a colon, and then the ID for the photo. And some enterprising engineer figured out that you could just split by colon and get the ID for the album, and they were off to the races, which was great until we changed the infrastructure for how you got to albums and photos, and then all that code broke, and we're like, wait, what? How did that break? Right, we were leaking an implementation detail. So ask yourself, what happens when our implementation changes? That might mean moving from SQL to Mongo. It might mean deploying microservices away from your monolith. It might mean lots of different things. But it probably means that the way that your data is stored and accessed is going to change in the future as your stuff evolves. And so think, does the API that I'm representing now continue to make sense when that happens? And what kind of encoding details am I letting bleed through when this is happening? And if we do this right, it lets us do lots of really awesome stuff. We can prototype fast, scale easily, and then deploy new services without ever interrupting our clients. And at Facebook, we've done this. In the last 4 years, we've shipped lots of infrastructure, new services, new stuff that ranks newsfeed, machine learning services, all kinds of really sophisticated stuff. And our 4-year-old iOS and Android clients still continue to work with the exact same semantic API. So these are the questions that came up as we were talking through these best practices. These are some of the most important best practices that have helped us maintain the same schema over 4 years at Facebook while continuing to build and ship new products, features, and infrastructure, most importantly, all the time. We derived these questions by asking ourselves how to evolve APIs. But now I want to take a little bit of a step back and talk about some of the lessons learned, not just from using GraphQL, but from actually building it. So I think if we look back, we can extract some of these principles into something of a design philosophy that helped guide both the initial development of GraphQL and the recent redesign. These principles guided GraphQL, but I think they're really just as applicable to building any kind of tool, library, language, anything like that. So if you in the audience are working on something like this, hopefully this is relevant to you beyond just GraphQL. And let's start with what's hopefully the most obvious. When designing anything, a language or a library, it's critical to start with solving a single important problem. For GraphQL, that was getting all the data that we needed for Facebook's newsfeed over iOS over increasingly terrible mobile network connections. This basically all but completely ruled out REST right away without devolving into, like the typical collection of random custom JSON endpoints with a bunch of resources jammed together in a way that clearly wasn't REST at all, and we just didn't want to do that. We actually tried that, and we abandoned it pretty quickly for obvious reasons. Also, don't just solve any problem, solve the most important problem that you can find. In 2012, it was a little bit of a while ago, and I'm not sure if you remember this, but our mobile apps were truly terrible at that time. In fact, when Zuck filed our IPO that year, he specifically called out the investor risk that mobile was driving an increasing amount of our daily users, and we hadn't figured out how to be good at it yet. So this was not a theoretical problem by any means. This was an existential threat to the company. Failure to adjust to major shifts like this has crippled or killed other huge companies in the past. So starting with an important problem grounds you. It keeps you honest about what you're trying to accomplish, and it helps you drive the early prioritization of features. The most novel aspects of GraphQL, giving clients control of data with hierarchical queries that can be resolved in one round trip to the server, these were all established within that very first initial prototype in response to the problem at hand. So remember to stay focused on what the most important problem is that you're solving, and use that to crystallize what it is that you're building. And we've heard a lot today about GraphQL first development, and I think that's actually really good advice, but what's driven us so far has been being client first and using client first development. Mental models are so important to how we think as programmers. Everything we make is ethereal, it's in our heads. But there's lots of different kinds of systems and different kinds of programmers and mental models, and they don't always match up with each other. So an important part of us designing GraphQL was being kind of unabashedly driven by the needs of the client, the consumer of the language. And hopefully it doesn't come as a surprise that not every great iOS engineer is also a top-notch network engineer and a database engineer and web API designer. Our iOS engineers, they just wanted to think in terms of model objects and the JSON data that they needed to make those model objects work, so we designed GraphQL to mirror JSON. And those who take a trivial look at GraphQL, they often accuse us of being database nerds, where everything looks like a nail for a database language hammer, right? And they foresee doom and gloom. But in practice, it's totally the opposite. We are product people, and we designed the API that we wanted to use to build products. So if you're building a new kind of language or a library, especially one that connects different kinds of systems and programmers together, try to escape the mental models of what it does, and instead put yourself in the shoes of the person who's going to be using it, and try to figure out what it is that they're trying to accomplish. For GraphQL, that was realizing that it was way more important to declare the data that you needed instead of how you got that data, which led us to the declarative query in the first place. Rethink established best practices. This tweet is one of my favorites. It was posted in response to us announcing React at JSConf in 2013. And this is relevant to GraphQL as well. Probably the most common question I got, especially right after announcing GraphQL, is why we didn't just use REST, SOAP, OData, JSONSchema, JSONAPI, RAML, Swagger, RDF, AL, or Corba. We're one of the other major established technologies for building APIs. Just because there's a best practice or even just some other tool that's out there doesn't necessarily mean that it's the right solution to your particular set of problems. And none of these were right for ours. So I think it's important to respect and to honor, and most importantly, to learn from best practices, but not to be held hostage by them. I love this interview with Elon Musk where he talks about reasoning from first principles, where he talks about not just evaluating technologies and ideas as they're described, but instead boil things down to their fundamentals and then work them back up with a good feedback loop. And speaking of having a good feedback loop, it's so important to have a real first consumer of your library or tool or language. Whenever you're designing something new, it's really easy to find yourself considering all the possible future use cases and possibilities and then wanting to design for all of them up front. But it's basically impossible to predict the details of all of those, and the devil's in the details, right? Otherwise, what you end up doing is basically guessing, and even the smartest of us sometimes guess wrong. And regardless of whether you're right or wrong, those decisions stick around, and they can lead to poor trade-offs or unnecessary complexity. GraphQL's first client was Newsfeed for iOS. We embedded ourselves on that team, and we let their needs and priorities drive how we were designing GraphQL. So when we had ideas for adding some feature to GraphQL, having this first client helped us ensure that we were actually solving a real problem that they had, rather than just our assumption of what the problem would be. But out of all the lessons learned, I think this one is actually the most important, and it's come up a couple times today, which is to provide an incremental adoption strategy. Our iOS team wasn't just going to start over and rebuild their entire data layer just because we made GraphQL. So instead what we did is we made it easy for them to replace one REST endpoint, one resource, one data model at a time, and roll things out iteratively so that they could make progress. And having this path for incremental adoption, I think it's critical for the proliferation of ideas because it lets you try out a new idea in the context of an existing application where things are already working, you're already measuring stuff like, is it fast? Do people like it? How many times are they clicking this button or whatever? So you can evaluate the strengths and the weaknesses of this new piece of technology before making a decision to just go whole hog and build with it everywhere. And I think the single worst strategic mistake that a software company can make is to rewrite everything from scratch, which is what happens when you don't have an incremental path. If your library or framework requires rewriting your entire app to adopt, then its adoption itself will be slow. Joel Spolsky wrote a blog post about this 16 years ago, which is nuts. This blog post could drive a car. And if you haven't read it yet, it's not too late. It's 16 years old, but it's still highly relevant. Go check this one out. All right, and speaking of adding features, your first response to every new feature request should be YAGNI. Do you guys know what YAGNI means? Yeah. If you do, you're going to say it with me, right? You ain't going to need it. That's right. Okay. I heard from some in the front, but now I got to hear from everyone, and I see people up top too. We're all going to say, what do we say to adding new features? You ain't going to need it. Yeah. Okay, good. This is one of my favorite lessons, and it was probably the hardest for me to learn personally. We want to avoid implementing things that we foresee we'll need in favor of things that we actually need to solve a real problem today. The burden of proof should lie on the new feature for proving that, yes, truly, we are going to need it. So ask yourself, can we solve this problem some other way with tools and features we already have? And if we can, but it's awkward, just how awkward is it really? Can we go without the new thing? Because when we add the new thing, what we're doing is adding cognitive cost. It's not just how hard it is to implement. Implementing stuff is the easy part. It's more to learn, and it's more to teach, and it's more stuff for future features to bump into. Have you ever tried to add a feature to something and go never mind, we can't do it because it conflicts with this other thing that we added poorly in bad taste a year ago? Yeah, that's what happens when we do these things. YAGNI. So during the redesign process of GraphQL, I was actually talked out of a huge number of proposals with this argument alone, YAGNI. And speaking of the redesign effort, it's really important to avoid the second system syndrome. This idea comes from the book The Mythical Man Month by Fred Brooks, which is one of my faves. It claims that the first time you build a new thing, you're a beginner, so you're going to be naturally conservative. But the second time around, you've got experience. You know what you're doing. You've got success under your belt. So you're going to pull out all the stops and do all the things you were too afraid to do in the first time, and you're going to end up totally over-designing it. And as the primary designer of the GraphQL language, this was definitely something that I suffered from. So YAGNI can help, but I think the best way to combat this is to have an editor. So as a designer, I have a propensity for ideas. I love to create new things, and I tackled this redesign effort with a ton of creative exploration, and I was pretty gung-ho about every idea that I come up with. I was like, I'm sure all of these ideas are great. But if I was a designer, then my teammate Nick Schrock should be considered the editor. His role was essentially to play devil's advocate, to be an all-around pain in the ass and argue against every idea that I had. But in doing so, he helped identify the proposals that meant well, but just weren't worth it. But once I was able to convince him that a change was worth it, he did a complete 180 and became the biggest advocate for it. This process also helped us clarify how we talked about GraphQL and the changes that we were going to make to it, which helped us pitch them to the rest of the company, and then later the whole developer community. And ultimately, my editor, Nick, he ended up being the best person to persuade others of what we were doing because he himself had been persuaded. So if you consider yourself the designer or the architect for a language or a library or tool or any piece of software, you should make sure that you have a collaborator who is taking on this role of an editor, because I think it's really, really hard to keep both of these competing mentalities in one person's head. And GraphQL changed a lot in those first few months, and we were able to do that because we sat right next to the people we were impacting. But later, as GraphQL was used across the whole company, it became significantly harder to change. We had to coordinate a lot more pieces. Change is still possible, even in a big company, but as we prepared to open source GraphQL, we realized it was going to be way harder to make significant changes after a lot of companies, all of you, had already started to rely on it. So while we were interested in redesigning GraphQL for a while, and I knew it was going to be a lot of work, it was really this drive to open source that sparked the motivation to actually make it happen. I think most of us open source our projects way too early, and I hope that's not too bold of a statement to make. I love and deeply believe in open source, but really it's the complete opposite of having a first client. If your idea really is great, then you can quickly get tons of clients. And that's not necessarily what you want for a young idea. Not only can it make it more difficult to prioritize, but it also removes a lot of the freedom to evolve and move quickly that's especially important during the early development of ideas. And GraphQL could maybe have not worked. It was lucky and beneficial that it did, but it was a huge risk to build something totally new, especially during a period of existential crisis about mobile apps at Facebook. And in my experience, solving a really important problem is typically when most engineering managers and teams would encourage sticking to what works and avoid taking what might seem to be unnecessary risks. And when Nick shared his first prototype, he definitely got a fair amount of pushback exactly like that. But ultimately, we were allowed to prove the idea mostly because of early enthusiasm from our first client, that iOS team. So some of the projects that I'm most proud of at Facebook started this way, including both GraphQL and React. And what I've taken away from it is not just to take risks, but in particular to trust experienced engineers like Nick to decide when the risk is worth taking and let them hold accountability for those choices. So if you run a team, try to push decision-making and accountability to your strongest engineers, especially if they think the time is right for something new. So from Nick's Supergraph prototype in 2012 to powering mobile newsfeed at Facebook to open sourcing it last year, to all of you using it, GitHub launching a public API, and this conference, GraphQL's already been through quite a lot. But it definitely feels like we're still in the beginning for GraphQL. The community is still growing really fast, and as it does, we're seeing a lot of more use cases for GraphQL and a lot of new and interesting ideas, opportunities for GraphQL to evolve further. But now that more people and projects and companies are relying on GraphQL, how exactly should it evolve? What is it that we should be striving for? And how should we evaluate changes to GraphQL? I've actually been thinking a lot about this lately. First, I think it's important to stay true to the original purpose of GraphQL, to provide a complete description of all the data that we need, all the data available in a service, and to let clients declare exactly what they need in single round trips. But there's some priorities that we want to maintain as well. And the first is backwards compatibility. So a huge reason why GraphQL is so useful for us at Facebook, and I imagine many of you as well, is because we're able to fulfill queries from iOS and Android apps that we launched years ago, despite changes both to our schema and to GraphQL itself. That means that we need to be really careful that the future changes to GraphQL are introduced without breaking existing uses whenever possible. And then there's simplicity and performance. I'm sure many of you have heard this adage, performance is a feature. And whenever we're evaluating new additions, we want to make sure that we're taking into account the performance of having those features implemented in real GraphQL servers. But more importantly, for GraphQL, simplicity is a feature. New proposals that simplify are going to be way more valuable than proposals that complicate. And then finally, there's stability and predictability. So GraphQL has already evolved quite a lot over the last couple of years, but it's going to be harder to do that now that it's implemented in a dozen languages and used by tons of different companies. It's important that we can continue to build an ecosystem of tools and services that are stable and behave predictably. So with these in mind, I've come up with a rubric, or sort of a set of questions that we can ask for any proposed change. Are we solving a real problem? Does this enable new use cases? How common are those use cases? Can we enable those use cases without having to change GraphQL? And if so, just how awkward is it? Remember, YAGNI. These also encourage collecting some data around showing just how common some usage patterns are, and it'll help us understand the value that any change would have. But also because GraphQL is being implemented by many different people for lots of different environments, it's really important that the evolution of GraphQL happens in a transparent way. And because people are using GraphQL in new ways beyond how we've just used it at Facebook, it's also really important that anyone can contribute. So we're really close to this since all development happens on GitHub, but I want to propose a slightly more formal process for this. And that's to center around RFCs and champions. So RFC stands for Request for Comments. And what it is a document that starts a conversation about a proposed change. It tracks prototype implementations and ultimately proposes the spec text to be added to the GraphQL spec. And these RFCs are all going to live on GraphQL in the open, so that as pull requests probably, so that everybody can easily find those and read them if they're interested. And behind each of these RFCs will be a champion. So a champion is someone who's willing to put in the work required behind developing an idea, writing that RFC, creating some fork of a popular GraphQL server library to implement it to see how it works, satisfying any concerns raised in the process, all the work involved in generally owning that RFC all the way from introduction to landing in the spec. And in addition to writing these RFCs, I think we should also keep a regular development cycle and release schedule. This process is going to be kind of intentionally slowly paced, but that's to make sure things stay stable and reliable. So first what we'll do is every month we're going to have a Google Hangout meeting where we can go through all of the open RFCs with the champions and with GraphQL server implementers to talk through concerns and to make progress. So stay tuned for the scheduling of the first of those. Then, every 6 months, we're going to release a new version of the GraphQL spec that will include whatever changes are ready. So when the 6-month time comes, the train leaves the station. That gives GraphQL implementers a predictable calendar of updates rather than having to just kind of chase the current state of the GraphQL spec. We've actually largely kept to that already. After initially launching the spec last July, we cut a version in October of last year, and then again in April of this year. And that means that the October version of the GraphQL spec is next, which will be arriving later this week. So I'm excited that we're making the evolution of the spec more of a community effort to include more folks in this room and beyond. But you may be thinking, I don't know if I have an idea on how to make the spec better. How else can I help? Great question. Developing the spec is not what I hope most of us are working on and focused on. It's really not where we need most of the work in the GraphQL ecosystem right now. Instead, let me look back on that master plan that I scribbled a long time ago. While we're way further ahead than I expected on most of these, where we definitely still need focus is in building and improving the tools for using GraphQL in lots of different environments. Whether that's building best-in-class IDE integration, performance analysis tools for GraphQL services, or better GraphQL clients on every platform, there's tons of opportunities for improvement across all of the tools that we're using. And I really think that great tools are what will make GraphQL ubiquitous, and that's where we need all of your help. So once again, let me just say how proud I am to get to close out this conference. Totally crazy that 4 years ago we started working on this project that today have all of you working on it. When we open sourced GraphQL last year, I really had no idea what would happen next, and it's totally exceeded my expectations to see so many high-quality presentations today from tons of different companies that are all using GraphQL in different ways. And what's really exciting is to see the community grow to the point where we can like barely fit in this room, and we're not all even here, right? Like only the people who showed up, and we still can barely fit. So please let me say thank you one last time for helping to make GraphQL what it is today, and just how excited I am for what we can all be building together. Truly, thank you all.